Hello class, here's a video for section 11.1. There's two main calculator functions you'll use in this section. One of them will be for problems like this where you're doing the confidence interval. So this would be down to intervals, this would be a 2-prop z interval. The other test you'll use in this section is when you're doing the hypothesis testing. This would be a 2-prop z test. So those are the two functions you're looking for. So the first one, let's go to 2-prop z interval. And we're just going to put the information exactly as they give it to us. So x1 is 30, n1 is 236, x2 is 32, n2 is 310, and the confidence level is 90%. And we get negative 0.022 if you round it, and 0.070 if you round it. So that's doing, and some of the later problems will ask for you to construct a confidence interval as well. It should be this 2-prop z interval for all of the ones in this section. The other type of problem, the tougher problems in this section are dealing with the testing, the 2-prop z test. Let me show you one of those. This is kind of a long one. So they're trying to compare the annoyance levels of males versus females, talking about people checking their cell phones while they're having a conversation. So the first thing to be careful of in this problem is the proportions. When they give them to you, they switch the order in the very first problem, which is not fair in my opinion, but be a little bit careful about that. So in the problem, they give you the numbers for males first, and they give you the numbers for females second. This very first problem, though, part A, they're wanting you to put the proportion for females first and for males second. So the first time I put it in, I got it backwards, so just be careful about that. This 3873, so if you do the proportion for the females, that's these numbers here, the 213 and 550. So if you go 213 divided by 550, that's how I got this 0.3873 right here. For the males, this number's for the males, you would do the 211 divided by 591, and that gives you this 0.3570. Those are just the proportions for each one of those. Okay, good. The parts that make this test possible, so the things that we need the samples to be independent. We need the sample size less than 5% of the population size. And we need these two, since we're doing two proportions now, we need both of these to be true. We did these in the last section, 10.3 or 10.2. So n times p times 1 minus p, you're doing it for both of the proportions. So as long as those are both greater than or equal to 10, then we're good. Okay, the null and alternative hypothesis. The null hypothesis always has equality. We've been talking about that. So this is claiming that the two proportions are equal, that the annoyance level for males and females is the same. The alternative hypothesis, this one's a little tricky to know if it's greater than or less than. You got to be careful. They're saying the first proportion is females. That's the way we set it up here in this very first part A. And so the P1 is females, the P2 is males, and they're claiming here, does the evidence suggest a higher proportion of females? That's claiming that the P1 is greater than or bigger than P2. So that's why it's a greater than test, not a less than test, so be careful. Describe the sampling distribution. The mean for this distribution, P1, according to the null hypothesis, P1 is equal to P2. The mean for the sampling distribution would be P1 minus P2. If they're equal to each other, then that would just be equal to 0. So this will always be true. This, I think, is probably where you're going to have the hardest trouble on this problem. The standard deviation for these two proportion problems. Let me show you what this looks like. The formula for this is right here. So it's this big square root problem. It's given in the section as well. So all of this is the formula, that big square root. So I plug those numbers in. So 0.3873, 1 minus 0.3873 divided by 550. 0.3570, 1 minus 0.3570 divided by 591. So if you put all that into the calculator, you get 0.0286. So that's the standard deviation you want to put into this problem. So that's where I got the 0.0286. Be careful about that. Plugging that into the calculator, it's a long problem. Be careful with your decimals and stuff. Okay, looking at the picture, so we're talking about, this is a right-tailed test. So the area would be in the right tail. So the only two possibilities, actually this is the only possibility that could work. I guess technically this one, but that area is very far off. That area can't be 0.3030. So this is the only picture that makes any sense with a right-tailed test. Determine the p-value in the test statistics. So here we go. Stat over to test. We're doing a 2-prop z test now. So putting in the x's and the n's. So the x is for females first 213. The n is 550. Oops. The X2 is 211. This one's for males. And 591. And the test, we're doing a right-tailed test, so it's greater than, and calculate. This should give us our test statistic and our p-value. Test statistic is 1.056. I rounded that to 1.06. And the p-value right here, not p1 hat, not p2 hat, not any of these other p's. There's a whole bunch of p's in this case, right? This very first, the second line there, p equals 0.145 is the p-value we're looking for. Okay, interpret this p-value. If the population proportions are equal, so if the null hypothesis were true, then the proportions would be equal. We would expect a sample difference proportion greater than the one that we observed in about 145 out of 1,000 repetitions. Again, if I multiply this p-value by 1,000, that would turn it into 145. I would expect that to happen about 145 out of 1,000 times. That's a tricky part too. Based on the p-value, what does the sample evidence suggest? So this is a very large p-value. It's much, much greater than the alpha. So we do not reject. When the p-value is bigger than alpha, then we do not reject, and we say there is not sufficient evidence. Do not reject, there is not sufficient evidence. Those always go together. So we pick that one. And that's it. That's the end of that question. I think that's the toughest part. Be very, very careful about this standard deviation here. I think that's where most people are going to make mistakes. So if you have any questions on any of those, let me know. But the rest of this homework, you should be using this 2-prop-z test. Maybe every now and then they'll ask you to do an interval, and that would be the 2-prop-z interval test. So other than that, just plug the numbers into the calculator and it should be good. Keep up the hard work. Let me know if you have any questions.